we're going to take a look at how to graph linear equations with domain restrictions. Now remember, our domain is our input values or our x values or our independent values. What it's going to look like is you're going to have just a regular looking equation here, and then you're going to have this piece tacked on at the end. This is our domain. And what we do is we will graph this line like it's a regular line, and then we're going to go back and we're going to look at the domain and we're going to cut it where it needs to be cut, because we don't get to use any x value anymore. We only get to use the values from 0 to 10. So what I need to do is I need to start at my intercept again, and I'm going to take my scale up by 2's. So my intercept of 5 is going to be right there, and my slope is -2, so I'm going to go down 2 and over 1. Down 2 and over 1. And once I get my points plotted, I can sketch my line through there, and now I'm going to need to go back and I'm going to need to restrict my domain. What this means as far as my graph goes is that I'm only going to pick x values from 0 to 10. Well, my x values from 0 to 10 are only between here and here. So what I need to do is I need to only keep that piece of my graph. So think about it as you're going to take a scissors and you are going to cut right down those domain values, that restriction, and you're only going to keep certain parts of your graph. Now this one says I want to keep the values that are less than 10 but bigger than 0. So that means I want to keep all these middle values. I have to go up here and I'm going to erase that part of my graph, and I'm going to erase that part of my graph. And notice I'm only left with a line segment now. These do not go on forever in both directions. Next thing I have to do is I have to look at my cutoff points here for my domain, a 0 and a 10. The inequality signs did not have equal to signs, so that means I need to have an open circle on both of these ends at my cut points, because that means that I can get as close as I want to that point, but I can't actually include it. It's not part of my graph. Okay, here's another one. So this time my equation is in standard form, so I'm going to find my x-intercept and my y-intercepts. To find my x-intercept, I plug in 0 for y, and I get x to be equal to 2. And to find my y-intercept, I plug 0 in for x, and I get y to be -4. So again, I'm going to go by 2's on my scale. So my x-intercept of 2 would be right here. My y-intercept of -4 would be right here. And then there I have my line. Now I need to go back to my domain, and I want x to be greater than 7. So this time I only have one cut point. So I need to take my pretend scissors and come over here to where 7 would be, and I'm going to cut my paper. Not really cut your paper, but I'm going to cut it right there. Now at this point, if you want to decide on your open or closed circle, you can. I need to have an open circle again because it doesn't have the equal to part with it. So I'm going to have an open circle right here where my graph meets that scissors cut. And then I have to decide, I want the x values that are bigger than 7. Well, if I go down here to my x-axis, numbers bigger than 7 are this little tiny right side of my graph. So that tells me that I'm going to keep this half of my graph. So I have to erase the entire thing here on the left side because that's not part of my domain. So that has to go. Now even these intercepts, these points that we used to plot it, we don't keep those either because they're not in the domain. So this is what my graph would look like for this particular one. I only want the x's that are bigger than 7. Okay, go ahead and see if you can do this one. So pause the video and see if you can first graph the line, then go and make the cuts like you have a scissors where they need to be on the -5 and the 3, and see if you can get this one to work out for you. Alright, on this one I haven't quite finished it yet. So if yours doesn't look like mine, that's probably good. I started by graphing the equation of the line. I went to my y-intercept of 4, and then I used the slope of -1/2 and got my line. Then I went over in these green lines right here. Those were the places where I cut it. So I went back on my x-axis to -5, put my scissors cut up there, went over to 3, and put my cut right there. And now this tells me I want to keep the x values that are between 3 and -5. So I put closed circles where my graph crosses my cut points because of the equal sign there. It means I can have them included. And I want to keep the graph that's in between there. So I have to erase both of my tails here for this particular graph. And once I get both of those ends erased, all I'm left with is this little line segment in between them. So that would be the graph of my function when the domain is restricted. Okay, here's another 2 practice ones. So go ahead and pause the video again and see if you can get the f of x one graphed. Alright, our f of x function started down here at -6. I went by 2's on my graph again, did my slope, drew my line, and then I went to my domain. My domain has to be cut at 2 and cut at 8, so I went over on my x-axis to 2 and to 8, and I cut them there and cut it there. Then I went back and I looked that I want to keep the values in between 2 and 8, so I kept the piece of the line that's in between there. And on the 8 there is a closed circle because it has the equal to portion of my inequality. On the 2 there is an open circle because it does not have the equal to part on the inequality. So f of x should look like this red piece right here. Go ahead and pause the video again and see if you can come up with g of x. Alright, on g of x, hopefully you didn't get stumped on this one. This one, start at your intercept of 5 is up here. Your slope is -3, so I plotted my points. There was no domain restriction, so this one is just a regular line. Nothing to cut, just a regular line for that one. Hey, here's another set of practice problems, and let's make the domain restriction on this one x has to be greater than -2. And on the one down here, let's do x is greater than or equal to 1. So go ahead and pause the video for each of these and see what you come up with for the graph. Okay, the one I have here is f of x. I went to my y-intercept of 2, my slope of -3, drew my line, and then I had to cut it at -2, so I only had one place to cut it. So I came on my x-axis and I cut it here at -2. And since it does not have the equal to portion with the inequality, I put an open circle, and I wanted to keep the part of the line where x was greater than -2. Well, x is greater than -2 to the right, so I keep the right half of my paper. Now don't get confused here on the direction the line goes. Even though my domain says I want x to be bigger than -2, my line is going down. That's because the height of the line represents your y values. Your x values are only on the x-axis. So if this is -2, right here's -1 and here's 0, this way is bigger even though the graph is decreasing. Alright, see what you come up with for the second one. So go ahead and pause that video again and try that one there. On this one, I was in standard form, so I found my x-intercept, I found my y-intercept, plotted both of those, connected them. Then I came over here to my domain, and I had to cut it at 1, so I went over to 1 on my x-axis and I made my imaginary cut. And this is telling me keep the half of the paper where x is bigger than 1, bigger than or equal to 1. So on my x-axis, bigger than 1 is to the right, so I would keep this right portion of my graph. So whenever you're graphing equations that have domain restrictions, start by graphing just the regular equation and then go back and you can do the imaginary cutting so you can see which piece of your graph you actually want to keep.